Okay, so welcome to lecture number 2 of electricity. In the last lecture, we were discussing on electricity, and in last lecture, we discussed about potential difference. Okay, potential difference. In this lecture, we are going to discuss about electric electric charges, electric charges and current. So to talk about electric charge, let's get into the most simplest atom, that is your hydrogen atom. Hydrogen atom, we all know that hydrogen atomic number is 1. So therefore, in the nucleus of hydrogen there is one proton which is positively charged, and around which goes electron in a circular orbit which is negatively charged. So electrons are negative and protons are positive. So these are fundamental fundamental property of subatomic particles. So subatomic particles. So because of charges only, they can experience force. So if the electrons are able to revolve in this orbit, it's because of the attractive force between this proton and this electron. Okay, so this negative and positive charge is the fundamental properties of subatomic particles, and due to which they can interact. Okay, they exert force to each other. Okay, so uh, building on this only, we can say if there are like charges repel each other. Okay, repel each other, and unlike charges attract each other. Attract each other. Okay, so now to before getting into electric current, so we can let's define what is electric charge. Okay, so as I said, it is a fundamental property of subatomic particles due to which they can interact with each other. Okay, so if I have to talk about the magnitude of charge, so the magnitude of one electronic charge is equals to 1.6 into 10 to the power minus 19 coulomb. So it means that 1.6 is divided by 10 to the power 19 coulomb. So this is the electronic charge. It's a very small charge, so even then we can determine it in the lab. Okay, in the experiment we can determine it. So the charges for proton and electron will be equal, so the magnitude will be equal, only the difference will be the nature of the charge will be a negative and positive. So just to denote, I can write a negative just because it is electron. If I write for proton, I will write plus 1.6 into 10 to the power minus 19 coulomb. Okay, so the SI unit for charge is C, and basically it is because C stands for coulomb, which is named after a scientist. Okay, now moving further. Okay, so moving further, let's talk about what makes conductors and insulators. Okay, what makes conductors and insulators. Okay, so now, because you know that everything in this nature is made up of atoms, so if all the things are made up of atom, so then why some are conductors? So conductors basically means which conducts electricity. Okay, electricity. And okay, so some wires, copper wires, irons are insulators, conductors which conducts electricity. And on the other hand, rubber, plastic, etc. are called insulator because this does not conduct any electricity, not conduct electricity, conduct any electricity. Okay, so if both are made up of atoms, so why they are different in nature? So let me explain this. Okay, so suppose, for an example, if I have a conductor, I have a conductor, and here I have insulator. I will draw it with a different color so we can differentiate it. Okay, so this is my insulator. Okay, so both of them are made up of atoms, so let this green color represents atom. Okay, so both of them are made up of atoms, so consider I'm making very few atoms out here. Okay, so in reality there are billions and trillions of atoms. Okay, so here also it is also made up of atoms. Okay, so but the difference out here is in this conductor you will get some free electrons. Okay, sea of free electrons. Yeah, there will be lots of free electrons in this conductor. These are called free electrons. In a while I will explain why it is called free electrons. Okay, but here there are no free electrons, no free electrons. So now if somebody asks what is the difference between a conductor and insulator, so then you can say the conductor, in the conductor there is a presence of free electrons, whereas in insulators there are no free electrons. Okay, so here this is conductor, this one is your insulator. No free electrons, no free electrons. Here is a free electron. Now let us understand what is free electrons. Suppose again I will take the example of hydrogen, but okay, so hydrogen has one electron and one proton. Okay, so I will, okay, so one electron and one proton. Proton is at the center. Okay, so therefore it is neutral in nature. Neutral in nature. Neutral in nature. So neutral means carrying no, not no, no net charge. Total charge will be zero. No net charge. Okay, total charge equals to zero, because whatever the electron gives, if you add with proton, then you are going to get zero, because you are, as I have shown, that the magnitude of both of these charges are equal, but they are opposite, just in the sign. One is negative and the other one is positive. Okay, so that makes the overall charge of this atom zero. Okay, and most of the atoms, almost all the atoms in the universe are neutral in nature. Okay, so but see, these type of electron are called bound electrons. These type of electrons are called bound electrons because their job is to go around the nucleus. Okay, so because of the electrostatic attraction between the proton and the electron, their job is to go around this atom. Okay, so therefore they are bound to this nucleus, so therefore it is called bound electrons. Okay, but say for an example, if I do something so that if I give some energy to this atom and say that I am able to free this electron, the electron goes outside the atom. So now the net charge of this, net charge will not be zero. Why? Not be zero, not be zero. So not be zero, not equals to zero. So that is because proton is there, but there is no electron to neutralize it. So therefore the net charge will be positive. So this kind of term I can say net charge to be positive. So this kinds is the positive charge. Basically, if there is a positive charge in an atom, so that shows there is a deficiency of an electron. Okay, electron, and it is denoted by, since this is hydrogen atom, it is symbolized by H plus. So this plus basically means it is positive and it is deficient of an electron. Okay, and particularly we call it as ion. Okay, and positive ions are called cations. Okay, cations. Okay, so now, and these electrons, so now this, if you see this electron, so this electron is not bound to this nucleus anymore. So this type of electrons are called free electrons. So which is free electrons. Okay, so the reference that I am giving of hydrogen is not correct for the conductors because I'm giving it because it's the simplest setup. So basically now if you see out here, so there are lots of free electrons in this conductor and there are no free electrons in this insulator, and this because of this electron going from one place to another, that is what we define it as electric current. That we are going to come later on. So but now understand the difference between what are free electrons and what are bound electrons. So bound electron has to revolve around the nucleus. There are no other options, but free electrons are not bound to the nucleus, so therefore they can move anywhere inside this conductor. Okay. So now let's move on to understand. Okay, so say for an example, if I have a conductor. Okay, I have a conductor. Okay, I have a conductor. There will be lots of free electrons out here, but they will be randomly moving. So some will be moving in this direction, some will be moving in this direction, some will be moving in this direction. Okay, so net flow of charge, net flow of charge will be 0 because this charge moving out here will be cancelled out by this charge moving in opposite direction. Same with all the charges, there will be billions of charges and everyone will be moving in some different position. Okay, so therefore there will be no net flow of charge. That means if I have to select one point out here, A and B, so no charge, no electrons, okay, will be going from this A to B. So therefore we can say the net flow of charge to be 0 in this case. Okay, so in the same scenario, okay, in the same scenario, what I'm going to do here, I have the same conductor. Okay, same conductor, but now I am going to uh, join this conductor or apply a potential difference across this conductor like this. Okay, so with the help of any DC battery. Okay, so it's a positive negative terminal, this is positive and negative terminal. Okay, so now what will happen? So if we know the concept of, if you have seen the previous video, so then we have done this part. Okay, so done this part. So if this is your negative terminal or the charges with negative plate, if these are positive plate, so then if I connect this to, okay, so then this negative charge will be going in this direction and the positive wants to go into this direction, the other direction, but the positives are ions which are heavier than these electrons, so therefore electrons will be coming towards the positive charge. Okay, so because for electrons this plate out here will be acting like a lower potential, and we have defined charges always flows from higher potential to lower potential. For electron this is higher potential and this is your lower potential, so electrons will be going from higher potential to lower potential. So all the electrons which were randomly moving before, now it will be going into this one particular direction, that is towards the positive charge. Okay, so all the electrons which are here will be drifted in this direction. Okay, okay, this net flow of charge, so all the electrons will be drifted in one particular direction. So this net flow of charge per unit time is defined as current. Okay, it's denoted by I. Okay, and it is how many charges, how many net total charges flowing per unit time. So that means if I select a cross section area out here, okay, out here, so this is my cross section area. Okay, so how many total number of charges that are flowing in a particular time in 1 second, say, so then that is defined as electric current. So Q out here is total charge. Okay, and current is due to flow of which charge? Electrons. Okay, and Q can be written as Ne, where N is number of charges. Okay, and E is electronic charge, which we have calculated. It is 1.6 into the 10 to the power 19 coulomb. Okay, and T out here is time. So therefore I can be written as Q by T. Okay, so the SI unit is ampere. SI unit is your ampere. Okay. Okay, so electric current can be defined as number of charges flowing per unit time. Okay, so then that is defined as current, and the SI unit is your ampere. Okay, if you see somewhere written as 5A, okay, so then it means it is talking about electric current. So electric current is what? Electric current is the flow of electron. So in this case, you can see the net flow of electron, flow of charge, or electron in this case is not equals to 0, because they are going from one place to another. So now let's determine the direction of current. Okay, how do we define the direction of current? Okay, so I will make a simple circuit out here. Okay, okay, so this is a conductor, just a magnified view of a conductor. Okay, just to show in what direction the electron will be traveling. So if this is my positive terminal, and if this is my negative terminal, so you know electrons are negative and it all will be flowing in this direction. So electrons will be flowing in this direction towards the positive side. Okay, so towards the positive side, and electron will be repelled by this negative side, so all the electrons will be flowing here like this, so away from this negative terminal. Okay, so like this. Okay, now so this is the direction of electron. Okay, so but the current direction, okay, the conventional direction of current is taken opposite to that of the direction of electron. If the electron is going from this direction, negative to positive, the current direction is always considered from positive terminal to the negative terminal. Okay, so here you can write uh, conventional direction, conventional direction from positive to negative terminal. The actual direction will be from negative to positive. Okay, so the direction which we are going to use, always remember, that is your conventional direction from positive to negative terminal, and but actual direction is from negative to positive. So but we are not going to use this direction. We are always going to make the direction of the current from positive to negative terminal. Okay, so let's see once more what we have done out here. So first we have defined what is electric charge. So electric charge is a fundamental property of subatomic particles, due to which they can interact with each other, so either pushing each other, either pulling each other, exerting force on each other. And then we discussed about conductor and insulators. Conductor have this presence of free electrons, whereas in insulators there are no free electrons. And then we talked about what is the bound electron and what are free electrons. Okay, so bound electrons are electrons which are bound to the nucleus. So in this case here, this electron needs to go around this proton. Okay, it has no other option, but these electrons are free, so leaving a net positive charge in this atom, which we also call it as ion, particularly cations. Okay, so that means, so there are lots of ions and electron in this conductor, but there is neutral atoms in this insulator. Okay, charges always flows from higher potential to lower potential, we have defined it. And when the conductor is not connected or not given any external potential, the electrons are in random direction, net flow of charge is 0. Okay, but when we give external potential, then the net flow of charge will be total charge by time. Okay, so that is what we define as current. Current is charge per unit time, where q is total charge, which can be written as n times electronic charge. N is the number of charges, and a is your electronic charge. Okay, and t is your time. So that's it. In next class we will be studying Ohm's law, which will be connecting which will be the bridge between this voltage and current. Okay, so okay.